The Webb telescope has now discovered a void in the very early universe that could validate Albert Einstein's prediction that we would never be able to see to the edge of the universe. However, what are we actually seeing here? Is it truly a void? And could this be the universe's beginning? Scientists may have found a startling fact. A strange void at the beginning of time may now confirm a remarkable prediction by Albert Einstein. Imagine how, a century ago, scientists gradually started to look beyond the Milky Way's edges. What they saw first surprised them. It was just hazy nebulae, but then it became clear that these nebulae were other galaxies. First, the small and large, Magellanic clouds appeared, then the Andromeda Galaxy, and finally the shocked scientists realized how many more galaxies there were. Based on these discoveries, theories like the evolution of galaxies and the infinity of the universe were born. Edwin Hubble then noticed that distant galaxies were moving away from us, and the idea of expansion was born. Shortly after Albert Einstein presented his theories of relativity, the Belgian George Lampt came up with the Big Bang. Throughout his life, Einstein doubted whether the universe actually had a beginning and an end, despite his fundamental acceptance of the Big Bang theory. Nevertheless, he was always certain about another intriguing question, even if the new discoveries confirmed many of the researchers' purely theoretical predictions from the 1910s and 1920s. He was convinced that, despite the advancements in telescope technology, humanity would never be able to observe the universe's origin and end. What is the connection between the emptiness found by the James Webb Telescope and Einstein's bizarre theory? The disastrous forecast made by Albert Einstein. Einstein was certainly one of the most important physicists of the 20th century, and he made many predictions that are still cornerstones of modern science. Today, one profound consideration was the aforementioned prediction that we could never directly observe the absolute beginning of the universe, and Einstein gave two interesting reasons for this. Firstly, the theory of the Big Bang, and other theories based on it, postulated that there was no light for hundreds of thousands of years immediately after the Big Bang. Today, scientists call this epoch the Dark Ages. So how could we see a point in time or an event with telescopes when there was no light? There are even some exciting answers to this question today, such as radio telescopes. These do not see, but hear. But researchers are pretty sure that the Big Bang was not a loud expansion, but took place in complete silence. Basically, the space in which an audible explosion could have taken place did not even exist. At the time of the Big Bang, space itself only came into being with the Big Bang and was formed as a consequence of this event. Radio telescopes detect waves that are usually far from the audible sound spectrum. Space hardly conducts any sound, only a few other waves penetrate the interstellar medium, which can be made audible using modern technologies. We would therefore not really be able to hear the presumably silent beginning of the universe we discovered, the cosmic background radiation back in the 1960s, and have since mapped it very well. This radiation is considered to be an after effect of the Big Bang, and much evidence for the Big Bang has been derived from it. However, the microwave background has never led us directly to the Big Bang. So here too, we apparently have no way of detecting or proving the absolute beginning, or Big Bang. However, Einstein was also of the opinion, for another reason, that we can never see all the way to the beginning or edge of the universe. He was of the opinion that the beginning would move further and further away from us due to the expansion and extension of the universe, and would therefore be out of our range of vision, so to speak. Albert Einstein. Also, believed at times in a curvature of all space. This means that the starting point could also be behind a kind of horizon that will forever obscure our view. Now imagine again that this was at a time when the best telescopes were only capable of blurring neighboring galaxies. Today, we know of the existence of millions of galaxies in a universe, teeming with galaxies expanding so much and getting bigger and bigger. It could be really hard to see far at all, but that's not true. Although our cosmos is so rich, the spaces between the galaxies and galaxy clusters are so large that we can now see 13. 6 billion years away with our telescopes that would be very close to the Big Bang, and with the James Webb Space Telescope, we are already pretty damn close, but the Webb telescope does not show us what scientists called the Big Bang. 100 years ago, the JWST found a strange void. You've probably heard that the JWST found a lot of very old galaxies that now even cast doubt on the Big Bang. But did you know that the JWST also found a strange void that might support Albert Einstein's theory that the universe was non-observable at the beginning? Absolute voids are mysterious spaces that are so empty that they actually defy relativity. But how can they support Einstein's theories about the invisibility of the beginning? This is initially explained by the fact that the emptiness was believed to be a sign of the Dark Ages, when there weren't many stars or galaxies at first. Some scientists think that the discovery at least validated the existence of this APO. But then the shock hit. The darkness revealed an incredibly far-off void. We also know of closer and more recent voids, but these voids already present problems. In the very early universe, voids are again scientific impossibilities because they do not fit with the notion of the universe's homogeneity, which is closely related to the Big Bang or expansion theories. Vapors are too large and peculiar. They are not uniform in nature and go against some of the tenets of our universe. A void does not really confirm Albert Einstein's prediction. However, the Webb telescopes seems to confirm the view of the brilliant scientist. In another way, the telescope has so far found no trace of a beginning or an early stage of the universe. The images of the allegedly extremely early universe only show structures and galaxies that do not appear much different from those we know from the universe. We can observe more closely, could a void have been the beginning of the universe? The question now arises as to whether a mysterious void could have been the origin of the universe. We cannot completely rule this out because ultimately we never know what voids really are, and these days we also have to admit that we do not know how the universe really began. Voids are probably empty, but we don't know that for sure either. It's possible that they contain some kind of matter that we don't know about yet. Imagine dark galaxies' voids really are sometimes interpreted as some sort of parallel worlds, and some scientists them as scarred tissue from the collision of universes in the multiverse. Other crazy theories claim that aliens darken the galaxies in a void to harvest energy. So you can already see that these mysterious voids challenge our scientists and lead to the craziest theories. Naturally, the possibility that our universe was formed in a vast emptiness is supported by the fact that we are unable to demonstrate the opposite, which raises the questions of how matter was formed and what singularities are. Since the cosmos is supposed to have formed from nothingness, how could we witness it if that was the absolute beginning point? After all, it was nothing, thus it was imperceptible to us. An event that was previously unknown is said to have disturbed this standstill at one point, and creation started from this tiny point. A singularity is a point at which all forces are either so concentrated that our dimensions of values and sizes fail, or everything that exists is concentrated into this one point. The point consisted of a fluctuation of possibilities that existed in a state of complete equilibrium. We find these mysterious singularities in another place in the universe, specifically in the center of black holes. Point: everything that we know and can see today came into being, which means that for you and me, all life on Earth, every star, and every exoplanet was contained in this tiny dot of nothing. One of the great mysteries of science is how an incredibly small dot of nothing can contain everything, and it's currently unclear whether we will ever be able to solve this puzzle. These, in turn, are found at the center of almost every known galaxy, and black holes are what are left over after stars of a certain size explode. At least that is what scientists believe. As we have now discussed, we have very little means of seeing the exact beginning of the universe, if it ever existed. Everything is based on calculations that made sense until the James Webb Telescope found something that contradicts our theories. The Webb Telescope indicates that the universe must be much older than we thought, or that its nature is very different from what all of our calculations predicted. One of the biggest mysteries in cosmology is black holes, which are incredibly heavy and likely contain infinite internal forces. As a result, we will never be able to fully explore this infinite point, which is one with the singularity, using traditional means. In order to achieve this goal, scientists are now using the intelligence of quanta, which are thought to be the universal information stores of the visible universe. Meanwhile, other chip technologies are depending on the storage capacity of water to generate unusual computing power. Click subscribe now to see even more exciting videos. All hopes are currently pinned on new supercomputers that, with the aid of their own intelligence, can decode the secrets of the universe and show us the true connections.